Ladies and gentlemen, welcome to my shop. Welcome to my channel. My name is Keith and I'm your host. Before we get started, class, how about the Pledge of Allegiance?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Peace! Peace! Amen.
We spent some time this morning with our 4.5-inch flapper wheel on my DeWalt grinder, and we blended all the outside surfaces, open air surfaces, with that, and finished the castings off. We're going to run the caps in the Bridgeport, and we're going to run the legs in the K&T. We feel we have enough brazed material on there to give the important areas enough material there to go ahead and machine and create the bearing supports for the yoke arm. And so let's go ahead. We're going to do the split lines first so that we can bolt the cap to the leg, and from there we'll go ahead and do the bore, which is a two-step bore. They have a little clearance out for the outside for the thrust, and then they have the diameter for the actual support of the yoke. All right, let's come in, and we have our little shell mill. This is how I set this piece up in the vise here. And these are 1/8 parallels, and I'm holding the piece with this parallel across the top so that I'm supporting this square with that face. I've already measured this thickness here, that thickness there, and I was within 5/1000 on both sides. I kind of kissed this flat on the Wilton just so I had something that wasn't rocky. And my very first thing I did before I figured out that was, if I put this in the vise, are both sides of this equal enough to hold it without pivoting, pitching, or twisting? And it seems to be fine. So I'm going to touch off, and we don't want to take it back down, clean it to the cab. We just want to have a nice flat surface that encumbrances around our bolt holes. All right, so let's go ahead and bring this on down. And I don't even know what speed I'm running on yet. I just put this in here. All right, there's 0 there. We'll set our quill at 0. All right, we'll lock that in. What speed we're doing fine. That's about 325. We could go faster than that, but that'll be fine. Okay. We're just going to go ahead and come into this. This is just auto feed on here right now. Pretty fast one. We don't see any back cutting in over here, so that, we probably are pitched down slightly. It'll be fine. All right, we're going to go ahead and we're going to take 10/1000ths off of this. Here we go. Alright, I mic'd this out at just about 250. And this one's like 230. So we got about 20 thousandths thicker here than here. So I'm going to take my indicator, set it up here like a surface gauge, and we're going to raise this or lower this 20 thousandths so that we can make this uniform thickness from side to side. We're only 1/1000th difference this way, so we're pitched pretty good this way in the vise. Okay, I lightly loosened my vise, but I set it at 0, and then we can just slide this across the top of the vise top, which is pretty level, and it reads we're reading about +1, but I just need to go ahead and make this drop down about 20. So I'm just taking my little punch here, and we're straight going right to that 20 right off the bat. And now we'll go back here, and we find that we're 10 plus. We can tap it up a little bit, reset 0. We're gonna go back and forth until we get our 20. And it looks like I have my 20 right there. We tighten down the vise. Alright, we're gonna touch off and take another cut. Okay, I'm gonna come down till I touch. I came in a little hard. That's probably 2/1000 there. I'm just going to take 10 from there. Probably should start fading out somewhere around halfway through there. I probably touched down more than a couple thousandths. Means that went a little farther than halfway across there. Okay. We're going to go ahead and take another 10. There we go. After this goes all the way across, we'll check our thickness again and we'll see how close we ended up being. 326, 327. We're doing good. We were reading that wrong before. I thought I had quarter or so, but we still had a difference of 20 thousandths. Okay, we have our small, I don't know what this is, like 2-inch shell mill here, and we have this face on the table, so we're holding it square. This casting has one flat side, and that flat side is 90 to this. Now, as far as the pitch this way, we measured from the edge of our table out to the base with our scale here, and we maintain 4/800 on both of these feet out from here. So that's how we're judging the squareness of this. All right. Now I'm going to turn on the light, which lets me see a little brighter, and we're going to turn this on, and we're going to come in and we're going to touch off, and we're going to go up and down and out to our two edges right there that'll locate that cap. This cap is going to sit on here, or sit in there, once this is machined flat, and then our bolts should bolt right up. Okay, let's reverse this. All right, and we can give that, we like that speed right there. Okay, just making sure. Okay, we're tight to the table. Okay, I saw a little chip come off of there. We're cranking this by hand, by the way. Okay, I want to see where I've touched. Okay, just barely touching a couple of the high spots there. I'm going to bring it back closer to center, and I'm going to go ahead and go in 20 thousandths. There again, we're hand cranking this up. All right, we're going to crank in another 20. All right, now we're going to feed down by hand. We're going to look at it from this side. I'm going to go in another 20. Starting to pick up more surface now. Brazed material is pretty easy to cut, and if you're rigid, you don't have to go slow. You can buzz right across it. None of the surface has to be a certain condition here. Okay, there's another 20. That's an accident waiting to happen, right? I was wondering why we weren't getting more action out of that. Okay, evidently I just stuck that holder, or that little shell mill in the holder, put it in my rack without tightening it up. At least it didn't suck it in. Okay. Now when we take 20, it might actually take 20, right? All right, should we see if it makes a difference? All right, first off, come on up. We're going to come in and we're going to touch. Okay, come on down. Take 20. All right, now let's see what it does. More betterer, right? Way betterer. $467, $450, $448. Really looks skinnier than there, but it's just deceiving. I have more well build up here, or braze build up, than I do over there. All right, I'm gonna go in 10, 15. Okay, now we're gonna come over to this side here. I gotta get my mirror. Okay. Crank her up. I'm eyeballing the center and the cutter just to get it in the center of the leading edge there. Now I'm coming into this side here, close to it. I'm trying to stay away at least 25, 30 thousandths for right now. Okay. Alright, let's get a nice look at it. You know, it's not too bad. We got some pretty good surface there. You want to come in another 10. Okay. All right. We've touched in one little area cast over here. That side there looks pretty good. We're going to go for side to side now. Hey, side to side's good. We've that's right in there. Yeah. Excellent. Little braze left on both sides, but I just eyeballed it to it, and we had a little luck in our favor. I like that. Okay, let's pop this out of the machine. Deburr them and put our two pieces together. We turned blanks for our bolts out of 12L14, 12L15, and out of hex stock, and we put these in and set up and did our 1/2 inch 13 threads like we did on those rods for the cranberry. I reset this head up. My second threading job, I'm using my new Geo head that Stan Sinkowski gave me, and what I'm making is this is 12L14 before I forget it, or 12L15 leaded stock hex. I roughed it out in the clothing, a bunch of my blanks, so I have a series of blanks over here, and I'm putting the hex in here, and I have the head flush with the outside there. They rotate nice and true because I've turned them true. Alright, I purchased a 5C BXA holder online. One of my viewers gave me a good deal. And 1-inch collet on it. And I paid for the shipping and everything. And got it here and set it up. The bore of this nut, or draw nut here, is the same size as the center here, so it lets me center the thing up really nice in the lathe. I've locked the height. I've played with the height and all of that, so now I know I can just set the block straight, set this on here, go in and out till I'm lined up with my center, and now I'm good to go. All right. This lever here is for rough cut and finish cut. When you engage it, and you can see the amount of advancement it does with the dies. All right, that was things that I figured out after the fact of my initial use of it, and also paying attention to comments in my video. Anyhow, we're going to go ahead and engage it. Also, I run this now with the pitch on the lead screw, so I go ahead and engage it. And I also have the travel set on the digital so that when I get to the point there, I can release it and the thing will automatically stop at that point. Got a real nice chip with this leaded stock. Then we come back and we flip this over to finish cut, and we engage on our same number that we were running on before. And this will take care of our finish cut. There we go. We're in business. In the lathe here, and I chose to run it in this 5C collet block on the compound so that I could use the two-stage cutting and time it with my thread pitch. I know a lot of you, and I do a lot of tapping and die running over in the closing lathe because my tailstock is real heavy duty. This tailstock on here is tall and lightweight and does not follow the bed really comfortable for me to put side rotational torque on it. Okay, I feel much more control, and this is the test here. We have the small 7/16 14. In fact, I didn't have dies. I had to order these on eBay. I got 6 sets for, I don't know, $80 or $100, something like that. And I found a set in here that is protruded out from the face, so it lets me kind of come right up to the shoulder. And these really are threaded up to about 1/4 inch of the bottom of the head. And this is one of the old worn out bolts that hold those bearing caps on. So we're threading these up and finishing up our bolts so we can bolt those caps on and do the boring for the trunnion pivot. Alright, let's go ahead and take, we have one chucked up here already. And this head is all centered up and zeroed in, just like I showed you in that video clip there of doing the longer bolts. See, I'm able to come right into that. I'm almost 1/8 of an inch away from it there now. So I've got it even a little tighter than the original one. Okay, now we lock this in and we go ahead and we advance our thread. We've been playing with our depth of our threads there on a couple bolts there, making them as tight as we possibly can. All right, and then our test nut. One of the characteristics to older bolts is dome heading or radius in the top of the head. All right, I've already done this one here. I set up a radius tool here. Let me show you how I've going about that. Okay, put in our blank like that. Fire it up. This is just form tooling. You can work a little bit on the radius. You come on in towards the face. You kind of just like rock it back and forth. You don't have to try to take the whole thing at once. And then you can kiss that off with the file there if you want. There's still a little flat there. You can actually get rid of that if you want. There you go. Just a quick form, but it dresses off the top of the bolt. Really makes it look nice. Underneath we have our shoulder diameter, and we did that when we turned the diameter. And there we are, finished bolt. We put this nice new Bessie clamp on here because this kind of holds both sides here flush. All right, and the nuts or bolts are loose, so they're free mounting in there. And now I'm going to tighten them up because we want to hold those bearing caps where we want them to be when they set in there, and hold the trunnions in line. and they're rough cast, and they don't. Right here, where the trunnion is, both of these are pretty close. And when we do the bore, we're going to make a finished bore, and that finished bore, we're going to locate the bottom up to center line on both of these so that we know we're horizontal. And then the mounting and fixing of these to the bell tower will justify the alignment, the finished alignment of support for the bell yoke. All right, I got both of these sitting on the table here, and I'm reading up here, and I got 15 inches 50 thousandths, 15 inches 50 thousandths, plus or minus 5 thousandths. We're going to take, and we're going to just call that split line 0. And then we're going to center up. We're going to center up that boss right there, and we're going to use, here it is. We're going to use this 1 inch 1/8 washer, and we're going to center up side to side with the meat of the casting. So we'll be on height, but we're going to center it so that the meat around the edge will be, and this is about the size of the large diameter, 1 1/8. So this will bring back that meat around that outside. So the hole all the way through is going to be 3/4 inch plus clearance for the shaft, and then 1 1/8 inch by about 300 deep. We got our tap follower in here because it's a pretty good pointy tool that lets us come down and really nitty gritty the eyeball on the point there. I don't have a edge finder or center finder with a point on it, so I like to use this. All right, we're center line with that. So we're gonna set our 0 in that axis, and we're gonna put this little 1/2 inch shank in here because this will allow us to put it down in this washer area here, and we're going to drag it side to side because that outside is a good visual of what that large diameter is on the trunnion or the yoke trunnion shaft. All right, I think that looks pretty darn good right there. Uniform all the way around on that cap. Remember, that was worn through. In fact, I think over here it was even broke through. All right, we're going to 0 that location right there. We're center with where our trunnion's going to go through. All right, now we need to go through with a pilot drill. All right, this is a 3/8 starter drill. We're locking everything down here. Now I'm just coming down here because I want to see if my dimple actually lines right up with the center line. That is so close. I'm just confirming. That's all I'm doing. Just confirming. I'm going to touch it again. I want to go in a little deeper. It's going to be close enough. Okay, now we're going to go with an undersized drill for that diameter. Okay, this is a 64th under 3/4 here. I've got a flat grind on the tip, so it shouldn't be grabby, but I'm feeding this down with my handle or my hand crank here for the auto feed. Okay. Nice. All right, let's vacuum that up and get a good look at it. This is really not bad. I'm taking a picture down in the bore looking that direction, and you can see two little spots of cast on the upper cap and the lower cap right there at the edge, just splitting the split line there. And let's take a picture off this way here. You can see a little bit of porosity in there, but material all the way around. Awesome. All right, we had to make a sleeve for this little boring bar to fit in here, so that took us a little while. Let's see, where are we at right here? There we go. Okay, we're gonna go ahead and we need to put our gear engaged here. And here we go. All we did is barely touch off and then lock it down. And we're through, and we're going to set 0 there. All right, let's get a snap gauge on that hole. Okay, I'm like 0.773 and a half or so. Now we know one of those journals is like right on the money and one's about 3 thousandths over. And we probably want like, I'd say like 3 to 5 thousandths clearance on this for plenty of adjustment for them to mount this bell up in the tower. So I'm going to say open this up about 4 thousandths. Excellent. All right, let's see what we got. Okay, I like that. 757. All right, we're gonna swap out now to our bigger boring bar. We got to go dress this edge right here, and then we're gonna be doing the counter bore. Actually, do we have to, or can we do it with this? We can probably leave this right in here and do it. I think I'm going to do that. All right, we're going to raise this up a little bit. Okay, we measured this dimension right here at 271, and we measured the width between our two shoulders on the one side that we're going to shoot for this to fit, that it's got to be at least 0.19 or 0.900. All right, so when we touch this surface right here, we're going to be taking from that point 371 thousandths. All right, and we're going to feed this by hand. And everything's tightened up on here, so we're just going to be looking for it to be touching in on this side over here. It may touch the main body first. And it does. Okay, it's just, we're going to call that 0. Now we need to go 371 thousandths. There's 100. There's 200. There's 300. All right, and it's just starting to skim the cast over there on that shoulder right there. That's at 350. I'm going to go ahead and mark that at 0 right now and pull it up. Okay, I'd rather go there, and if we have to sand a little bit off of the back side, I'd rather go ahead and sand that. I know we added a lot of material in there. All right, let's go ahead and we're going to go another 100 thousandths. That's 50 a side. That diameter is 0.862, so we should be somewhere around 962. Okay, here we come. We probably could slow this down a little bit, but I am taking quite a bit off per pass. A 100 left to go. $50 to go. We're going to start hitting the cast. Okay. Okay, we are going to slow her down now. Okay, I like that. Okay, let's see where we're at as far as this dimension going. Yeah, 1960, 61, 62, somewhere around in there. And another 100. 40 to go. Starting to hit the cast. Alright, there's our 0. You know, we may have made our trunnions a little tighter also, so it doesn't matter. We're going to have brand new material there, and that's what it's all about. Alright, and we just want to keep an eye on our diameter. So we got 1 inch 58 or so. Okay, 1 inch 58, and we want to go just slightly over 1 1/8 because that's what that diameter is there. Okay, so I think that figures out to about 67. We'll go ahead and we'll take 70. $30 more. We're just starting to hit the cast. 10 more. Okay, there's our 0. Okay, I'm gonna vacuum that out. Not bad, not bad. Okay, let's see what we got here. One inch 130 or so. All right. I think I want to leave it just like that. Take this thing out and do a test fit. Let's get the other one in here and do the same. All right, we're all set with our bell. She's ready to go to the customer. Okay, we're going to leave it set up here so that he gets to see it all set up. And then we'll take the counterweight off and all of that. All right, until the next video, get her done.